Hi ladies and gentlemen, my name is Webs from slidenerd here. In this video, I'm going to talk about static variables in Java. Now before we talk about what is static and before I begin my process of telling you exactly what goes on, let's directly try to understand why do we need static variables with the help of a simple problem. So here I have a unique problem which says assign a unique number to every object being created. In other words, every time you create an object, keep a track of the number of objects that have been created. Now each successive object should have numbers like 1000, 1001, 1002, 1003 and so on. Now of course you could have 1, 2, 3, 4, but then I took this case as a simple example. So first let's take a look at one of the possible solutions that you guys might come up at this point. You can have a class test which has an int id here. This class is gonna be the guy on which we are gonna create objects. So for example, you could go to your main method here and you could simply say test is new test. So the first time you create an object and it will be something like this. You have your test reference variable that's pointing to an actual object test. Then you'll say test.id is 1000. Same way you'll create another object test2, that's another reference pointing to a separate object of type test. Then you'll say test2.id is 1001. So is this what we want? Well, not really, because here if you guys notice we are explicitly giving values. We're saying test.id is 1000, test2.id is 1001. What we want is the values should be automatically given when the object is created. So how can we do that? Well, we can have another solution which looks something like this. Class test again, int id is 1000. There is a constructor this time. So let's try and understand why we have a constructor. And inside the constructor, if you guys notice, I'm saying id plus plus, which means I'm increasing the value of id by 1 whenever the constructor is getting called. So now let's take a look at the main method, try to understand what is happening. I said test is new test. So at this point, if you remember, my constructor is going to get called, id will become 1001. Test2 is new test, which is a separate object of test that we have. Again, the constructor is called, id is 1000, it becomes 1001. Test.id, test.id, if you print both of them, you guys are gonna get something like this. Now let's try and understand what is happening. First, test reference variable points to an actual object which at the time of creation id is 1000. As soon as you create the object, the constructor gets called and that makes it 1001 because we have set id plus plus over here, right? Same way you have test2 is new test, test2 reference variable pointing to object whose id initial value is 1000, but the constructor gets called and id plus plus makes it 1001. My question to you, is this what you want? Not really. If you remember, our problem said that count the id every time a new object is created. In other words, what we want is first it's 1001. Next time you create the object test2, it's 1002. Then if you create say test3, that becomes 1003 and so on. In other words, the id variable is not separate for every object. What you have is a common id variable for all the objects out there and you just increase it once. So how do we do that? That is why we use a static variable. Now again, don't worry, I will show you exactly how this works, but for now just bear with me and take a look here. Now this time what I say is int id is 1000 and I make this as static. I use this word static in front of this variable here. Now I have my constructor the same way as I had earlier and I say id plus plus, nothing great, it's just the same thing except this red colored word static here. Now again, if I go to the main method, I say test is new test and then I print it out. Test2 is new test, I print it out and my program gets over. Now let's try and understand what happens this time. First you have the test reference variable that points to the test object, right? The constructor gets called and then id becomes 1001. Now notice something very weird. This id variable does not belong to the object anymore, it's kept separately. So when you have test2, the reference variable that calls the constructor test, this time id becomes 1002 from 1001. There is a single variable ID that is maintained for all the objects, no matter how many objects you create. In other words, this variable ID does not belong to any specific object, or you can also put it this way, that any object does not have its own copy of the int id variable. It's a common variable that every object is trying to access over here. In other words, the id variable belongs to the class test this time. If you guys notice the syntax over here, I have said class name dot variable name. Now this is completely different from what you guys saw so far. All this time what you guys saw was object name dot variable name. For normal variables, that is how you access them. But since id is not contained inside the object anymore, what we assume is that it is contained inside the class, and hence we use class name dot variable name here to access the static variable. Now again, we will show the working of this exactly in the next video when we talk about static. So some points for you guys to remember would be this: static variables belong to the class instead of the object. They are just a single copy of the static variable that is kept for all the objects, no matter how many objects are there. Now they are accessed using class name dot variable name outside the class, and of course only one copy of the static variable is maintained across all objects, and every method of a class can access static variable, including the constructor. It's just like any other variable that you saw, except that it is maintained uniquely. So class-wide information common to every object should be static. So one of the questions that you guys probably have is, when should I make something static? Now it completely depends on your situation. If there is something which is common for every object, then the simple policy is that you keep it static. For example, the interest rate inside a bank is common for all the customers, all the accounts, and in that case you can make the interest rate as static by saying interest rate is 8.5 something. So now let's talk about how you can initialize static variables. Again, if you see, there's a class test, and what I have is static int id, static boolean my condition, static char c, static object a, and so on. So at this point, if I go to my main method, now notice one thing very carefully. I'm not creating any objects because these values are not maintained within any object. They are kept separately, so you can directly access them. I can say test.id, test.myCondition, class name.c, class name.variable name. This is the syntax I'm using here everywhere. So at this point, if you execute this, what is going to be the value for each of these variables over here, because we have not initialized any one of them? Well, very simple. If no value is given, static variables are initialized with defaults, which means 0 for numbers, false for a boolean, the 0 a sky value for character, and null for objects. So is there any other way to initialize static variables without having a constructor? Yes, there is. If you take a class test, I have a static int id is 1000. Well, this time what I've done is nothing great. I've simply given values right at the place where I have declared them, just like any other normal variable that you guys are dealing with all this time. Again, if I go and print them, test.id is 1000, test.myCondition is true, and a and new object, whatever it comes out to be. And again, remember, give explicit values directly inside a constructor, or you can put it right here. Now this is one of the ways, remember, but if you do not want to initialize that, you can of course use the constructor here and a special block called the static block. Now take a careful look. There is static int id, there is a static block over here where I say id equals to 1000. Now when I say block, notice carefully, it just has an opening bracket, closing bracket, and I have written static over here, where inside which I have said id is 1000, and it says system.out.println look I am first, and below that there is the constructor of our test class over here, within which I simply say constructor called. And right now if I go to my main method and I create the object by saying test equals to new test, here if you take a look at the output, take a look I am first. In other words, the contents of the static block execute even before any object is created. In other words, this runs first and then the constructor runs saying constructor called. Again, I'll be demonstrating this in NetBeans in our next video when we take a look at sample code. So use a static initialization block whenever you want to give values to static variables after your class is loaded. In other words, you don't want to use a constructor, but you want to give them values, but not directly. You can use a static block over here and execute some other statements inside the static block, like for this system.out.println that I have. So now let's take a look at another thing about static blocks. The same class, the static block with id 1000, and I say system.out.println, look, I'm first. This is gonna run before anything else in the entire program. Then there's the static block again, and there's id is 1001, and it says system.out.println, look, I'm second. Now first question, is this legal? Yes, you can have several static blocks defined separately. What will happen is all of them are combined into a single big static block starting from top to bottom. So in this case, if you have the constructor at the bottom here and you say system.out.println constructor called, let's take a look at the output and try to figure out what happens. I've simply created an object of test over here by saying, so the first thing that's gonna run as soon as your program starts is gonna be this static block here, which is gonna make id as 1000, then it's gonna run this statement saying, look, I'm first. Then the second static block will run where id is 1001, it's to say, look, I'm second, and after that your constructor test gets executed, within which your println statement is called, saying constructor called over here. Again, we'll be demonstrating this in NetBeans in the next video. So if more than one blocks are defined, then all the blocks are cascaded in the order in which you wrote them. So that's the simple explanation that we have for this statement here. So remember some tips with static variables: make constants as static and public. For example, 3.14, which is the value of pi, deserves to be a static variable because no matter which object you're gonna create, 3.14 remains the same everywhere, right? Then if static variables are not constants, then try to keep them private. Then you can save space using static variables by keeping only one single copy of a value across all the objects that you have in existence. So this pretty much completes our stuff about static variables and static initialization blocks. In the next video, we are gonna jump into NetBeans and we're gonna work static stuff out. And in the meantime, if you guys do like what you saw, please like this video, share this video, subscribe to our channel, and let us know your thoughts in the comment boxes below. Thanks for watching. We'll catch you guys in the next video. Have a nice day.